Pulsars are the lighthouses of the galaxy. When the first one was discovered in 1967 by Jocelyn Bell at Cambridge, astronomers jokingly called it LGM for little green men, but it was soon realized that pulsars are a natural phenomenon. Fast-spinning, highly magnetized neutron stars that send out regular directional pulses of radiation as they whirl around. We see the beams as a flashing point of light if they happen to sweep across our line of sight. Today, almost 3,000 pulsars are known, almost all within our own galaxy. They were found originally at radio wavelengths, but have since been observed at optical, X-ray and gamma-ray energies. Most were formed when massive stars exploded as supernovae, leaving behind collapsed cores more massive than the Sun but only about 20 kilometers across, made of neutrons packed tightly together. A newly formed neutron star spins around many times a second and generates an immensely powerful magnetic field. This field accelerates electrons to near-light speed above the pulsar's magnetic poles. The accelerating electrons in turn produce the radiation that we see. Other mechanisms too are at work, which produce some of the X-rays and gamma rays that we detect. Pulsars last on the order of microseconds, while the interval between pulses, known as the pulse period, is typically about 1/4 of a second to 2 seconds, but can be as short as 1 to 10,000th of a second in the case of millisecond pulsars. The pulse period gradually lengthens as the neutron star loses rotational energy, though some young pulsars are prone to glitches, probably due to star quakes, when the period abruptly changes. A star quake is thought to happen when the crust of the neutron star settles a little bit. The discovery of millisecond pulsars with pulse periods of less than 10 milliseconds was puzzling to begin with. The reason for this is that the youngest known pulsar is the one in the Crab Nebula. It's only about 1,000 years old and has a period of 33 milliseconds. Since pulsars slow down with age, how could some older pulsars have shorter periods? The answer is that millisecond pulsars have been spun up, becoming what are called recycled pulsars by the transfer of matter from a companion. Almost all the 200 or so known millisecond pulsars have been found to be part of binary systems, in which the partner is a white dwarf, the presumption being that the pulsars were rejuvenated by the transfer of matter, while their companions were still in the red giant phase. Plaques attached to the outside of the Pioneer 10 and 11 spacecraft now heading for interstellar space carry information about the human race and its whereabouts. Lines forming a radial pattern on the plaques are labelled with binary numbers, which stand for the periods of 14 pulsars in terms of the spin-flip transition frequency of a hydrogen atom. The relative lengths of the lines indicate the position of the Sun, while changes to the periods over time will give a measure of how long ago the probes were launched. You might say the plaques are a long shot, in more ways than one.